Okay, there we go. All right, so we're now recording, guys. So the rest of the mathematics will be posted here, just like all of our other meetings. The one last thing I do want to note before we actually get going with the math is project packets, just how you're submitting it. Please do me the favor that I've been asking for a while now. Please include your name in the scan for each of, whatever you're scanning for the project packet, whether you're only scanning all the documents under one file or you're scanning, like 5 or 6 separate files, because I know some of you guys are still doing that, and that's okay. I haven't really gotten on you for doing that because maybe you don't fully understand how the OneDrive app works, and that's okay. But please put your name in each of the scans. So if you're scanning 7 different times, for all 7 of your scans, you have to write your name somewhere in the title of it, because it gets incredibly tedious for me to try to keep everything together, all your graded materials, when everybody just their project packet. It's very difficult for me to grade that. I have to individually write your name on every single one of those PDFs, and I'm telling you right now, if I have to do that, you're going to start with 5 points taken off of your project packet. Okay, so this is recording, so this is you have me on record saying this. If I have to write your name on every single one of these scans, then I'm taking 5 points off of your project packet, because I've been asking this for a while now. Okay, so please make sure that you're scanning and you're putting your name in the scans. Yes, Zenaida.
And you're just saying for each file, right? Not for each page.
Well, each file would be okay, so you're one of the people that you've incorporated all of your pages under one file when you scan, and so I don't care about the actual piece of paper. I'm saying that the files that you're sending me when you're submitting them have to have your name on it, and I know that yours does, so you're fine. I'm saying that when you actually scan something, at the top, when you're about to finish scanning it or sending it to me, it always asks for it normally, like, the default name is like scan and then the date and then the time, and then you change that to be like quiz 3 or quiz 7 or what have you, right? You have to make sure you're putting your name in that title when you send it to me. Okay, all right, any questions on that before we get going? We still have a quiz this Friday? Yeah, probably. I believe so. I haven't made it official yet, but I'm gonna go ahead and assume yes. I will let you guys know for sure on next Wednesday, like this upcoming Wednesday, whether or not we have a quiz. But the answer is probably yes. Okay. All right. So now that we got all that stuff out of the way, we can actually get to the mathematics here. So let me pull up here. I promised I would go over the homework question, 73, I think it was. I believe it was 73. It was the one where we had to get the form of an equation inside, basically a logarithm. All right. So yeah, it was 73. So 73, and I'm going to post a solution to this later today, just so if anybody missed this or if anybody wants to go back over it, you can definitely go over it. So what we're looking for with 73 from the last homework was, first off, we were given 2 solutions. We were given 1, and we were also given 1, 2. And what we're looking for is we're looking to get an equation in this form. We're trying to get y is equal to c plus b log base a of x, right? So this is the form of the equation we're trying to get, and we were given the 2 solutions, 10, 1, and 2. Okay, so the idea here is very much the same from the last example from the last lecture that I posted. So if you watched the last lecture and you watched the last example, you're basically following that along step by step, except you just have different numbers plugged in. So I told you guys I expected you guys to have the 5 steps at least written down, even if you didn't understand what to do with them. As long as you understood that there were 5 steps here and you were following along with the 5 steps, then we can absolutely solve this together, right? So first things first, who can tell me what my first step is? And in fact, in the last class, we even started it off right before the quiz. So what's my first step when I'm trying to solve one of these questions? Yes, Keji.
Create two different equations.
Yeah, right. So I have two different solutions here. So with those two different solutions, I'm going to create two different equations. I'm going to do the second one first, and we'll see why in a second. But the idea here is you're creating two different equations given the solutions that you have. So what do 10(1) and 1(2) correspond to? Remember, these are solutions to an equation, right? So if they're solutions to an equation, these are ordered pairs, which means that this is going to be your x, this is going to be your y, and this is going to be your x, and this is going to be your y for your two different equations. So let's go ahead and make them. And again, the first thing that I'm going to do is I'm going to use the second one first. So that means I'm going to have 2 is equal to c plus b log base a on, well, what's x? X is just 1, right? And next thing is for the second equation, we're going to have 1 is equal to c plus b log base a on the value 10. Okay, so all I did right now is I just plugged in my x's, I plugged in my y's, and I have two separate equations. Okay, somebody other than Keji, what's my second step? My first step was just make the two equations, right? So we did that. We have two equations now to work with. What's my second step now that I have that done? Subtract. Yeah, Gabriella, thank you. So the idea is what we're going to do, we have our two equations. We're going to subtract one equation from another. And I know that we got this far at the very least in the last meeting. So if you got stuck from here on out, totally okay. But I expect you guys to at least get this far. So what I mean by subtracting one equation from the other is you're subtracting one column from the next, right? Notice how I line this up. We have y over y. We have c over c, b log a over b log a, right? So just to kind of illustrate this, I'm going to draw little columns here. And we can see how everything is matching up, right? So what should 2 minus 1 give you? Well, 2 minus 1 should just give you 1. So we have 1. We keep our equal sign. And c minus c is just going to drop out, right? C minus c gives you 0, the same way anything minus itself gives you 0. And this is good news because now that c drops out, that's one of the variables that we're trying to solve for. So now that it drops out entirely, well, that makes solving this a lot easier because now we're just solving for b. So, okay, well, c goes away, and now we just have b log base a of 1 minus b log base a of 10. And you can't do any subtraction with logarithms. We need to use one of the rules that we have. But before we can get to that rule, there's a small simplification that we have to do first. So point is okay, we've done our subtraction of equations. We're now left with one equation, right? But with that one equation, we're also just left with the one variable we're trying to solve, which is b. So, all right, now what I want to do is I want to try to isolate b, right? I'm solving for b, so that means isolate it. And in isolating b, well, I see I have b in both of my terms on the right-hand side, so I can factor that out. So I have 1 is equal to b times log, my g's are coming out terrible today, log base a on the value 1 minus log base a on the value 10. Okay. So we've gotten this far, and now what we have to consider is solving for b. So how do we go about doing this? Well, we should consider one of the rules that we have, right? If I have logarithms and I have subtraction going on, what's the first thing that I need to check before I can apply basically any of my rules? There is one thing in particular we need to check when we're either subtracting logarithms, adding logarithms, or dividing logarithms. One thing for these needs to match. Yes, Gabriella again, thank you. They have to have the same base. If they don't have the same base, you're out of luck. That's it. You're dead in the water. You can't do anything. You can't simplify them. But if they have the same base, then you're in business. You can do things. You can apply the rules that we've learned. So they both have a base of a here, which means that, yeah, we can absolutely apply the rules that we've learned. So they're separated by subtraction, which tells you that you're going to be using your quotient rule, right? So we have 1 on the left-hand side. We haven't touched this. We have b on the outside. We still haven't touched that. And when we have 2 logarithms that have the same base and they're being separated by subtraction, we can condense them into 1 logarithm using the quotient rule, which says, okay, this is 1 log. We keep the base the same. And what should happen here if we are subtracting logs? Quotient rule, right? Quotient rule implies that the values of those 2 logarithms are being divided. So it's log base A on 1 over 10. The 1, because that's the first logarithm, goes to the numerator. The 10, because that is the second logarithm, that goes to the denominator, right? So we have now simplified this greatly, and so we have log base A of 1 over 10. And the last thing that I want to do here is I want to, again, isolate for b, right? We're still solving for b, so I'm going to move over this logarithm. I'm just going to divide both sides by this logarithm. And dividing both sides by this logarithm essentially gives me b is equal to 1 divided by log base A of 1 over 10. Now, at this point, we can actually simplify this a little bit more, but it might be a bit of a struggle to understand how we would simplify this a little bit more, and also why, right? Right now, we have b isolated, we've solved for b, and sure, we have a fraction with a logarithm in the denominator, but this is, for all intents and purposes, if we were only solving for b, this would be a totally acceptable answer. And so, again, it would be very difficult to see why we are trying to, or where we would try to simplify this. So before we simplify this any further, let's go ahead and jump to our next step. So first step, again, just to recap what we've done so far, first step was create your 2 equations, which we just did. Second step is you're going to subtract 1 equation from the other, which we also just did. And your third step is you're solving for, one of your variables. In this case, we're solving for b. So we solved for b, and now our fourth step is we're going to plug this back. We're going to plug our value of b back into one of the equations. And once we plug it back into one of the equations, notice how when we plug it back into one of the equations, we're going to have c in there. So we're going to be trying to solve for c next. How did you get b isolated? So we saw that we had b times some number. It happened to be a logarithm, but it's still b times some number minus b times some other number. So I just pulled b out of both. It's the same thing as if you just considered it as b times a minus b times c, right? You can always factor this by pulling out the b from both, and you're just left with minus c, right? So we had b times log of whatever minus b times another log. So if I pull the b out from both pieces, I just have the 2 logs being subtracted, just inside of parentheses. And then since I have an equation here, I divided both sides by this logarithm, and then b is entirely by itself. Does that answer your question?
Yeah, thank you.
Yep, perfect. So we have b is equal to 1 over log base A of 1/10. Okay, sure, no problem. Let's go ahead and plug this back into one of our equations. Now, the equation that I'm going to plug it back into, if we're considering what is going to make our lives easier, what you should try to tend to notice is things that are going to make your life easier in general. Now, if it doesn't really matter which equation you plug it back in for, either way, you'll come out with the correct answer for C. But I want you to notice here, we almost have what we need for the second equation. So our second equation is 1 is equal to C plus B log A base 10, right? And notice that when we plug in for B, our logarithm is going to be in the denominator, right? And the second thing that you should notice is that means we're going to have a logarithm up top, so in the numerator, because this is being multiplied, and we're going to have a logarithm in the denominator, so maybe we can get these to cancel out. And the way, again, that you should approach this as far as considering which equation to plug into is, again, notice how close this logarithm looks to this one, which means that if we can kind of mess with the logarithm here to make it look like the logarithm that we want in the second equation, then we can get them to cancel out, And, well, then we'll just have C by itself. Now, I know that that really may not make a lot of sense, at least not immediately. So let's first plug into the equations, and then, it might make a little more sense what I'm trying to get at here. So again, the equation I'm going to plug into is 1 is equal to C plus B log A on the value 10. So this was one of the equations that we created, and now we plug in our value for B. So our value for B just goes right into the equation that we have. So we have 1 is equal to C plus, and now our value of B is 1 over log base A 1 over 10 times log base A on the value 10. Again, notice how close these are to canceling out. If, hypothetically, just real quick, if hypothetically this weren't a 1 over 10, if this were just log base A on the value 10, then you could immediately cancel these, right? You'd be done. You'd be entirely set with, canceling these out, and then you would just have 1 is equal to C plus 1, and you'd be done, right? But unfortunately, we're not quite there yet. We do have a 1 over 10 inside this logarithm, not a 10. So we have to do some sort of manipulation before we can, do this cancellation. So what I want to do is I want to figure out how to manipulate this logarithm in the bottom so that way I can do this cancellation. Now what I want to do is I want to consider how to make 1 over 10 look like a 10. Well, we know one of our exponent rules, right? If we have a fraction, and I'll just start with 1 over any number. If we have 1 over A, our exponent rule says this is equivalent to A to the negative first power, right? We can always take a fraction and make it look like an integer just to a negative exponent. So if I have 1 over 10, I can make it 10 to the negative first. So sure, that's exactly what I'm going to do here. I'm going to replace this. So rewriting, I have 1 is equal to C plus 1 over log base A, and then 10 to the negative first power. And this is still being multiplied by log base A on the value 10. Okay, we also have, again, we can't do this cancellation just yet, right? Because we have this negative 1 power. So we have to get rid of that power. But we have a logarithm rule when it comes to powers on the value inside that logarithm. What can I do with this negative 1? This is something that I would expect you guys to know at this point for logarithms. How do I handle this negative 1? Somebody other than Gabriella. Yeah, thank you, Aline. So our idea here is we have the power rule, right? Power rule says that if we have an exponent on a value inside of a logarithm, we can take that exponent and make it a coefficient. So I'm going to rewrite this one more time. And for the record, if you saw most of this, you don't have to rewrite this as many times as I'm doing. I'm just doing this for the sake of clarity. So this is 1 is equal to C plus, and then we have a minus 1 over log base A on the value 10. Right? That negative sign would move in front of the logarithm, but when you have a negative sign in a fraction, that's basically just making the entire fraction negative, right? So it doesn't matter where I put the negative sign in. It's just the entire fraction is negative. So for the sake of that, before I continue writing, I'm just going to make it C minus. Okay? Hopefully we're all good with this. All I did was I moved that negative exponent out front, and it was just a negative 1. So it just made the fraction negative. So instead of C plus the fraction, it's now C minus that fraction. And this is still being multiplied by the log base A on the value 10. And now notice what we have. We have log base A and the value 10 in the denominator being multiplied by log base A with the value 10. So what we can do is we can just cross these out. And we're done with those. We got rid of the logarithms. So now we have 1 is equal to C minus 1. And this is super easy. We just solve for C. Just add 1 to both sides, right? Which means C is equal to 2. So now we have a value for B. Now we also have a value for C. The last step that we have in our 5-step process for this is plug them both into the form that we want and simplify. So one more time, the form that we wanted is y is equal to c plus b log base a on the value x, right? So what I want to do is now I just want to sub everything in. So substituting everything in, we have y is equal to, c was 2, right? So if c was 2, I'm just going to be plugging in 2, plus, we still have that entire fraction for b, right? So we have 2 plus log, at this point what you could do is you could either plug in you could either plug this piece in that we solved for b, or you could realize that what we did right here, is the exact same thing. So because you're going to have to do this manipulation anyway, so I'm just going to plug in the negative version of it that we just found out, where it's, the negative fraction of log base a on 10 instead of this positive version where we had the 1 over 10. Okay, so regardless which one you substitute in, they're equivalent. I'm just saving time by plugging in the negative one. You're going to have to do that anyway. So if you plug in this fraction, you're just going to have to make the same conversion that you did in this process right here. Okay, so instead of it being the positive, we're going to make it the minus 1 over log base a on the value 10. And remember, this is still being multiplied by this logarithm right here, right? So log base a on x. Okay, we're almost done, but I want to simplify this. Right now, I have a logarithm in a fraction. I have a logarithm being multiplied to it. This doesn't really look that clean. This really wouldn't be a good final answer. We want to make sure that this is as simplified as we can get it. And also, right now, we have this log base a. Do we know what a is? No, and we never really solved for a. So I want to make it in the form where a doesn't really matter, where it doesn't matter what your base is. So the way that I'm going to do that is, again, notice I have a fraction times a logarithm, right? And whenever you have a fraction times any number, that's essentially just this piece that's being multiplied goes to the numerator. So rewriting this one more time, hopefully, we have y is equal to 2 minus log base a over x and log base a of 10. Okay, we're really close to being done. What's the last thing that we can do here? Remember, now we have a log over a log. Before we even check to, any of our rules here, what's the first thing that we need to check? Again, Gabriella said it earlier, the first thing you need to check before you do anything is you need to make sure the bases match. So in this case, great, bases match, we're good to go, we can proceed to one of our rules. This is not going to be the quotient rule, even though we have a division, because remember, quotient rule is the subtraction of two logarithms. What this is change of base. This was directly coming out of the last lecture that we looked at. This is change of base, right? If you have one logarithm over another, as long as the bases match here, what you can do is you can condense this into one single logarithm. So we keep the y, we keep the 2, we keep the subtraction. Does anybody think they know what this one condensed logarithm is going to be? I'll take any guess at all. Yes, Keji.
Would it be log x over log 10?
I'm sorry. So just what's my base here?
A.
A. Okay. So close. Remember that when we're doing change of base, the idea with change of base is that we're changing it to some other base, right? So you can think about this as your final product. If we started with a logarithm, change of base says we're taking that one log and we're making it a division of 2 where we choose the new base, right? When we're going backwards, the base, this base here doesn't matter anymore. So we're essentially doing change of base, but just in reverse. But that was a good try. So I'm seeing a lot of answers in the chat here. Just to quickly look at it. Yeah, it looks like a couple of you got it right. Yep, so the idea is when you're going backwards with change of base, and change of base is, again, when you have the division of two logarithms whose bases match, the bottom value is always going to be your base. Remember, if we were going in the opposite direction, just real quick, if I gave you, for example, this logarithm just as a hypothetical, and I said change this base to be base 10, right? Well, base 10 would be, okay, you have log of base 10, which is the common log, so I'm not going to write the base, log of base 10. And remember that the base becomes the value, right? So the base becomes the bottom value. And then your top value is still your top value. So it'd be log of 3 over log of 2. So if we're going backwards here, remember that this essentially came from the base of the original logarithm, right? So it's log base 10. And again, because it's log base 10, I'm not going to write the base because it's the common log. And then what's our value? Well, our value is simply just the value of the top logarithm. So log of x. And we have substantially simplified it, and we have our final answer. We now have an equation in the form y is equal to 2 minus log of x. Okay, so one more time, let's just recap what we did, because I know that this question is quite a bit. It's very hefty, and that this is, the reason that I didn't want to go over it in class before the quiz, because I knew I just wouldn't have enough time. So the first thing that you're doing, you're given two solutions. We know we want to get it in this equation, in this form, right? So what we do is we set up two equations. That's your first step. Set up two equations with your solutions. Second step is you subtract one equation from the other. So subtracting leaves us with this piece right here, this underlined piece. We factor for b because we're trying to solve for b. So if we have two instances of b, which are both currently underlined, and what I want to do is I just want to solve for that one variable, well, I'm just going to factor that variable out and try to move everything else to the other side, right? So we used the quotient rule first before we moved it over, but that's okay. In the end, we did end up dividing both sides by this logarithm, so we got a value for b. So great, b is solved for. Your next step is you're going to plug this back into one of your equations, and you're going to be trying to solve for c now. So we plugged back into one particular equation because we saw that if we can manipulate the denominator of that fraction, then life would get a lot easier because we could just do some cancellations. So we used our logarithm rules. We used an exponent rule to make that 1 over 10 look like 10 to the negative 1. And our power rule, we can just bring that negative 1 to the outside. So that essentially made the fraction negative, and then we saw we had the exact same value in the denominator as we did being multiplied, so those canceled out. And when those canceled out, that just left us with a really easier linear equation, so c was equal to 2. And your final step is two values that you solved for, so in this case c was 2, b was that negative 1 over log base a of 10, and you plug them into the form that you're trying to get one last time and do any simplifications that you need to make. So don't think that this right here is your final answer, although if you got this far and this were a question on a test, this would be by far the majority of the points, but I would be looking to see this change of base going on, and this here would be your final answer. Y is equal to 2 minus log of x, because look how much simpler that looks than this monstrosity. Okay, any questions on that before we move forward with anything else? I really want to make sure that this type of question is understood. Again, it just comes down to, understanding you have 5 steps and trying your best to adhere to those steps. If one of those steps doesn't make sense, that's okay, but I need to know where, I'm losing you guys. Okay, I'm taking silence as you guys are golden, as I always have. So we're golden with this. I'm going to move forward. If you guys do still have questions on this, again, I have office hours 3 times this week, so try to make it to one of them. Okay, so for the remainder of the class period, there is about 15 minutes left. I composed a little worksheet which is on Blackboard. I think it's titled 11/16 classwork or page or something. Point is, it's not in any of the folders. You just go to the content area and it pops up there. But if you don't want to open it up right now, that's totally fine. What I want to do, there's a series of questions on there. There's 7 questions that kind of date back to things that we started looking at after the midterm. So this is kind of a review worksheet of, things that we've looked at that you really haven't been tested on, you've only been quizzed on. You could almost think about it like a final review, but I'm going to make the final review a little more in depth than just this. So, don't think that this is just your, the final review, and especially when we're still a couple weeks away from the final. So I'm not going to go in order here because I want to hit on things that I think are pretty important. So I'm actually going to start with the last question first, which is question 7, and then whatever we have time for, and we'll go from there. Okay, so question 7 says the following. I want to show the following. So I want to show that log base b on the value x squared plus 1 plus x. So again, keep in mind this plus x is outside of the square root, but it's still inside the logarithm, plus log with the same base b on the value square root of x squared plus 1 minus x. Again, notice the minus x is outside the square root, but still also inside the logarithm, is equal to 0. So I want to prove this. I want to show that this is actually true, that this logarithm plus the other logarithm actually gives me 0. So we see here we have 2 different logarithms, and they have a bunch of stuff going on here, right? What's the first thing that I check before I do any of my logarithm rules, before I try any of my, logarithm stuff? What do I always need to check? This is now the 3rd time I'm asking this because I really want to hammer this down. Same base, exactly, right? We need to make sure the bases match. If the bases don't match, you're out of luck. That's it. It's that simple, okay? But if the bases match, then you're in business. So we have the same base here, right? They're both base b. I don't know what b is, but it doesn't matter because if it's 7, it's 7 for both, right? So it doesn't matter what that value is. So I have log of base b for one, log of base b for another one, so we can use our rules. What's the next thing that you should be looking for when you're trying to evaluate logarithms? Well, the next thing that you should be looking for is see what's going on between the two, whether you have division, multiplication, subtraction, or addition, right? So what we have going on between the two is addition. We have 2 logs that are separated by addition. So what should that kind of clue you in as? What rule should we be looking for here? There's a particular rule that says if we have 2 logs being added, we do something with those. Yeah, Keji, one more time.
The product rule?
Product rule, yeah, Zenaida, same thing. Yeah, exactly. So if you have an addition of 2 logarithms whose bases are the same, this lets you know that you're considering to use the product rule. And product rule says we're going to take our 2 logarithms, condense it down to be 1, and the addition of 2 logs means that the values of those 2 logs get multiplied, right? That's where the product rule gets its name. So let's go ahead and do that. That's a really good first step. Let's condense it into one single log. So we have log of base b, and by using product rule, we're going to have, and I'm going to use brackets for the outside because just for the sake of clarity, the brackets are for everything that's a value of the logarithm. So we're going to have square root of x squared plus 1 plus x times square root of x squared plus 1 minus x. And hopefully this is actually equal to 0. Okay, what's my next step here? Well, my next step should be that I want to actually do this multiplication, right? But God, this looks terrible. We have square roots, we have x squareds, plus x, minus x. What should you be looking for here? Obviously, I wouldn't pose this question to you if this were impossible. This is definitely possible, and every single one of you guys can do this. Well, it looks like we have the same terms, right? We have an x squared, a square root of x squared plus 1, and square root of x squared plus 1, right? So we have this piece matching this piece. And then we have a plus x and a minus x. And yeah, Gabriella got it already, but the idea is we have a plus b multiplied by a minus b, right? So what do we know should be the resulting sequence here if we multiply a plus b times a minus b? Gabriella said the name, but I wanted to make sure everybody understands what we should get. What should we get here? Somebody spit it out. This is my favorite form. This is my favorite factoring for the entire class.
Is x squared plus square root of x squared plus 1.
Oh, well, but don't even worry about the actual values. What should I just get from multiplying a plus b times a minus b?
Oh, just a minus b squared.
A minus b squared.
A squared minus b squared.
Perfect. A squared minus b squared, right? Two squares and a difference. Difference of squares, right? Yeah, this is difference of squares. So we know we should get a squared minus b squared. We already know what a is. We already know what b is, right? So we just simplify this. So we have log base b, and the value should be, well, a squared. What's a squared? If we have the square of square root of x squared plus 1, that square root should just go away, right? So a squared is just x squared plus 1. And then we have minus, because it's a squared minus b squared, right? So a squared was x squared plus 1, minus b squared, and b is x, so minus x squared. And this is still equal to 0. And this simplification, I'm pretty confident all of you guys can make, right? We have an x squared plus 1 minus an x squared. So this should just give me log base b on the value 1 is equal to 0. Well, yeah, x squared minus x squared, that goes away. We just have 1. And what is our last rule? How do we actually prove that this is a thing? We have a property of logarithms. What does my property of logarithms say? My property of logarithms says if I have any base, I don't care what my base is, if I have any base, as long as it's, a properly valued logarithm, which means that my base can't be negative and it can't be, 0 or 1. It has to be a positive number that's not 1. But as long as my b is, a properly valued base, then if I have the value of 1 inside my logarithm, this is always 0. So 0 is equal to 0. We have now, in fact, shown that this is correct. Okay, so to get from here to here, this is just a property that you guys should know. If you have 1 as your value for any logarithm, then it's always 0. Okay, and for the piece above here, if you're wondering how I got the x squared plus 1 and the x squared, again, this is difference of squares, but if you don't see the difference of squares formula, that's okay. You can still do the foiling, right? It's going to be a little messier, but it's still absolutely okay to do, right? If we have, and I'm just going to write this all off to the side. So again, we have square root of x squared plus 1 plus x, and square root of x squared plus 1 minus x. And I wanted to FOIL this. Well, FOIL, first, outside, inside, last, right? First is square root of x squared plus 1 times square root of x squared plus 1, right? So first is square root of x squared plus 1. And then you realize, oh yeah, this is really the same thing as square root of x squared plus 1 squared. And oh yeah, these are just going to drop out, right? So that's how we got our first term, which is x squared plus 1. And then everything else, again, will proceed as normal. I'm not going to go through the whole foiling process, but I really just wanted to show that this is entirely doable by foiling. You don't have to see the difference of squares, but it really helps if you do see it by now. Okay, but point is, you get your x squared plus 1, the same as we got over here. And to get the minus x squared and all the pieces in between, which end up canceling out anyway, you just continue foiling. Okay, any questions with this question in particular? What I really want to hammer down is the steps that we took, right? The first step was verifying the bases match. If the bases match, you're good to go with logarithm rules. If the bases don't match, you can try change of base formula, but it's going to be messy. And point is, you can't just jump to the other rules. You have to make sure that the bases match first. Second thing is we noticed it's separated by addition. So because it's separated by addition, that should clue you into what your next step should be, which should be the product rule of logarithms. So going to the product rule of logarithms, addition of 2 logs means it's 1 log, keep the base the same. Where their values are multiplied, that's where product rule gets its name. And we haven't touched the other side of the equation. It's still equal to 0, right? And then by difference of squares formula, we know we can simplify this down, or by foiling, either way, however you get there. You get inside x squared plus 1 minus x squared. That just comes out to be just 1. And so you have log of any base on the value 1, which is always 0. Okay? Okay, So the last question that we're going to get to today, because we only have a couple minutes left, I just want to just touch on this one more time because I feel like the last time I went through it, it was a little bit rushed, although it's probably going to be a little bit rushed now anyway. So if you do have the page open from Blackboard, what we're going to look at now is question number 5. If you don't have it open, that's fine. I'm going to write it out here in a second. So give me 1 second here. If we have the following, so let's say we have if we have $2,000 being compounded continuously, which I'm going to abbreviate, please don't hate me. So if we have $2,000 being compounded continuously over 5 years, and we get a total of $2,550, what was the interest rate? Solving to the nearest hundredth. Real quick, Keji, is solving question 10 on the project packet similar to that? Yes and no. Yes, your first steps are going to be the same. The exact same first steps that we just took here, verifying your base, checking to see what the operation is between the logarithms, and using that operation to help you do some manipulation to the equation. Yes, all those steps, basically exactly the same. But there is going to be a caveat that comes up where you're going to be stuck unless you know how to freely go between logarithms and exponential form. If you don't know how to do that, then, you know, you're kind of lost. But you do need to be able to go to exponential form for question 10 on the project packet. In any event, so we have if $2,000 is being compounded continuously over 5 years, and it gives me a total of $2,550, what was the interest rate to the nearest hundredth? What was interest rate? Okay, so I'm really not so concerned about what my final answer is going to be. What I'm more concerned with is understanding and making sure that, you know, how to set this up. So remember, we have not just one, but 2 different formulas for compound interest now, right? We were originally introduced to compound interest using the exponential form, and that is A is equal to P times E to the RT, right? This is our exponential form, and we also have a logarithmic form, right? And our logarithmic form is when we solve for essentially when we move over P, logarithmic form essentially allows us to, you know, have R and T not as exponents anymore. So what we end up getting is we get the natural log, and I'm just going to put an arrow between the two because these are totally convertible. We get a natural log of A over P is equal to RT. Okay, so ask yourself, with all the pieces of information that we were given, which formula do you think we need to use? And if you don't see it immediately, that's okay. Just take the pieces of information you're given and write it out, right? So we are given $2,000. So you know that $2,000 is going to be your principal amount. So P is $2,000. We actually also know our total, right? Our total amount after it's all done is $2,550. So we also know A. A is $2,550. Okay, so if we know A and we know P, then that means that our unknown, which in this case is the interest rate, is going to be in an exponent if we try using the first one. And if we try plugging in, you know, everything into the first one, and also I probably should write out one more thing, time is 5 years, right? So if we try plugging it into the first formula, we're going to be kind of stuck because then our unknown is inside of an exponent, and how do we get it out of the exponent? That's really the question here. So that's exactly what this form of compound continuous interest does for us, is that notice how the interest rate is not in an exponent anymore. All we have to do is just solve for R, right? R is our unknown. We know T, we know A, and we know P. So if we move T over in the second one to the left-hand side, then R is entirely by itself. So that's all we have to do, right? So again, the key here is identifying which equation you need to use, the left or the right. And we decide on the right because R or T is one of our unknowns. If we knew the interest rate and if we knew time, and that would mean that we don't know the principal amount or we don't know the final amount, then you're absolutely using the left-hand side one. But because we don't know what R is, we're going to use the right-hand equation because notice how easy it is to solve for R here. Okay, so all we have to do is just take our formula, which again is the following: A over P is equal to R times T, and just plug everything in. So plugging things in, we have the natural log of our total, which is 2550 over 2000 is equal to, we don't know our interest rate, but we know our time, which is 5, so 5 times R. And solving for R, this just means divide both sides by 5. So we have the natural log of 2550 over 2000, all being divided by 5, is equal to R. And at this point, I would totally expect you guys to just use a calculator and give me an answer. And the final answer that you end up getting when you plug this into a calculator is, again, the question says round it to the nearest hundredth. So it's 0.05, which is 5%. Okay, so I'm not really too concerned with my final answer here. What I'm way more concerned about is getting to this point, getting to the circled here. Because if you can get to here, that means you're understanding which form to use and you're understanding just how to plug things in. Okay, so again, the idea is we knew the principal amount because principal is your initial amount. We knew the total because it gave us the total. And it also told us how long it's happening, right? The only thing that it didn't tell us, which is what we're solving for, is the interest rate. So if we don't know the interest rate, it's way easier to solve for the interest rate when it's linear than when the interest rate is in an exponent. Okay, so you would use the right-hand equation for this. And one more time, you use the right-hand equation, the logarithmic form, whenever you're solving for your interest rate or time. If you're solving for your principal amount or your final total, you use the exponential form. Okay, so this isn't homework. Although I am going to, for anybody who's stuck around, I know I just went over by a couple minutes, I'm going to offer you guys a little incentive for question 7. If you guys do, if you find the domain of question 7, I'll give you 2 bonus points on your next quiz. Okay, so this is due, by Friday because your next quiz, that's Friday. There's no, nobody gets anything negative if you get it wrong. You don't get any points off if you don't do it at all. Just freely giving you the opportunity to get a little bonus credit on your next quiz. If you show me the domain, then you get 2 bonus points. However, that means you have to show me all the work. And also, I am only giving you 2 bonus points if you get the correct answer with the work shown. If you don't show the work or if you get the wrong answer, I'm not even going to give you 1 bonus point. Okay? So, because you have multiple days to get this done if you want to. But for all the other questions, I'm not collecting them. It's just something to really think about for these, the questions above. If we have more time throughout the week or, going on later, then we will, try to look at it and I'll try to go over more things with you guys. Which question? It's question 7. Question 7 is the one. So that's the one that we actually did just now with the logarithms. If you find me the domain of that, then I will, give you 2 bonus points. Yes, Amanda.
This is on like the homework, right?
This is the again 11/16 thing that is posted on Blackboard.
Okay.
So yeah, it's not in homework. Can I scroll down? Sure. Sorry. So it's not in the homework. This is its own page. Question 7 is the final question on here. So if you can find the domain, great. If you can't, no sweat. You guys have other bigger fish to fry. I get it. Totally fine. So at this point, I'm going to go ahead and end the recording. Guys, don't forget office hours today, tomorrow, and Wednesday. So try to make it to at least one of them if you guys have questions. And if you can't make it to them, please let me know so that way I can schedule something with you. Okay? So ending the recording here. Have a great day.
Thank you.